geometries. This video is going to be for 4-2B. Yesterday, we would have talked about side, side, side congruence. Okay, side, side, side. Well, there's going to be a lot of times where we don't have all three pairs of sides, or we can't get all three pairs of sides. So we need some more tools. We need some more options that we can use when side, side, side doesn't work. So today's abbreviation is going to be side, angle, side, okay? And it's in that order. So we can't have, this doesn't work if the angle that we have is not called included. So this is specifically side, angle, side in that order on a triangle. So like S, S, A wouldn't work, and swear words wouldn't work. So you can't swear at me when you're talking about why triangles are congruent. So this angle is called an included angle. Okay, and that's what we have a picture of right here. So this is a picture of side, angle, side. We have BA congruent to SR. Okay, we have another pair of sides, AC congruent to RQ. All right, but then most importantly, we have a pair of angles. So before we get to that part, there's this third pair of sides, this yellow pair. I can't say that those are congruent. All right, they're not reflexive, they're not marked, so I don't have enough for side, side, side this time. So what they did give me is they gave me this angle that kind of connects those two blue pairs of sides. So this is called side, angle, side. And this is the only order that it's going to work in. And the reason that it works is if I made this red angle a little bit bigger, this yellow side would have to get a little bit longer. Okay? If I made this red angle a little bit shorter, the yellow side would have to get a little bit shorter. So if these two red angles match, then they're setting those yellow sides to be exactly the same. Then those sides would have to be the same length, and then we have side, side, side anyways. So these two triangles are congruent by side, angle, side. So congruent statement, maybe I scrolled a little more than I wanted. Okay, let's call the first one triangle, let's just go ABC. Okay, we have the triangle, or we have the angle A is marked congruent to angle R. So I'd have to start with R, and then I would have to go SQ. All right, by side, angle, side. So that's what we're looking at for this one. Okay, the animation is kind of what I was trying to explain. Okay, I can't, that's not clickable, so I can't pull that up. But as you change that included angle, that side gets longer. All right, so then you'll get questions like this. What additional piece of information would you need to prove that these are congruent using side, angle, side? So I want to use a pair of sides, another pair of sides, and the angles in between. So that's what I need to be, able to finish this problem off. So what they gave us so far is a pair of sides, and they gave us a pair of angles. Okay, what I need is a third pair of sides, and this is that idea of making sure that this angle is an included angle. What has to happen here is this side, this one I'm making blue, would have to be congruent to this one I'm making blue. That keeps the purple angle in between the other two. So what my answer would be, okay, what additional piece of information I would need we would need CB to be congruent to MK. Okay, the blue sides would have to be equal to each other. All right, this one says, what other information do you need to prove these two triangles by side, angle, side? Hey, this one, they've only given us one thing, one pair of angles. Okay, so when that happens, we have to get a little bit more. So what we do know is we can always add our braid to the picture. Okay, this red side is congruent to itself. Okay, we know that this is one where we'd have to switch the order, but we know that LB would be congruent to BL by reflexive. So we can get that by ourselves, though. That's not our answer. Okay, we would need something else. Okay, what other information do you need? So we would need one more pair of things. We need another pair of sides. We have a pair of S's, we have a pair of A's. Okay, we need a pair of sides that would keep that blue angle in between the two sides that we have marked congruent. So that would be like the top and the bottom. If the top was congruent to the bottom, okay, then that blue angle would be included between those two sides, in between. So we would need, we can call this one, let's call the top LE. Then that would have to be congruent to the bottom, which is BN. Okay, so this is our answer. Okay, we already know reflexive. We're allowed to do that whenever we want, but we need that top to be congruent to the bottom. Okay. Next, looking at just things we're allowed to do. Okay, that help us get extra pairs of angles or extra pair of sides. So there are main reasons that we can use the most to justify unmarked angles being congruent. So vertical angles. Okay, we've talked about it already. When it looks like a bow tie. All right. So in this situation, these angle x's have to be congruent. Angle BXA has to be congruent to angle DXC by vertical angle theorem. Okay. Another one is alternate interior. Okay. In order to be able to use that one, we need to know that the lines are parallel. Okay, the trigger for this one is parallel lines. Okay, so once we have that these are parallel, that's what these arrows mean. Now we have two pairs of alternate interior angles we could do. So we could get A congruent to C out of that picture, and we still have the vertical angles in the middle, but we can also get B congruent to D. So we can get both of those. Our reason for that would just be alternate interior angles theorem. Okay. All right, so those are two things you might be able to do. Now let's revisit our proof reasons chart. Okay, it's like the second or third page of the note packet. We did that on day one notes as we complete this proof. All right, so we have x is the midpoint of A, G, and NR. Okay, we want to prove that ANX, triangle ANX, is congruent to triangle GRX. Okay, so with any proof, we're going to take what's in the given and we're going to copy that down, okay, right away. So let's see. All right, so we're going to take x is the midpoint of A, G, and NR. Okay, we copy down the given word for word, and that is what we put in our given. Let's see if we can figure out what that means, okay, how we can use that. Okay, we can use that for really two pairs of sides, and that's what we're going to do right here. So what we know is x is right in the middle of AG. Okay, the first thing that tells me is that AX can be congruent to GX. Those two red pieces. They're saying X is right in the middle of those. Okay, but that's not the only one we're able to get. Okay, because it's also the midpoint of NR, which tells me NX has to equal RX. Okay, what we're doing is we're just using what's in the given to say why those two are equal. And they're equal because of the word midpoint, definition of midpoint. At that point of the proof, okay, now we have to look at what can we get. If we look at our picture, okay, if we were going to get side, 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 we would have to be able to get these two congruent, but I don't have a way to do that, okay? So that's not going to be my best option. They're not reflexive. I'm not going to be able to get those blue sides. But it is a bow tie proof, and I know that these vertical angles in the middle have to be equal. And at that point, I have those blue angles that are in between the two pairs of sides. So that's exactly what I want to do. I want to use a vertical step, all right, to say that these angles are equal. If I name the left-hand side AXN, that would have to be congruent to GXR. All right, and now I've got 3 pieces of information. I've got 2 pairs of sides and an angle in between. So that's going to let me conclude this last piece here, ANX and GRX. Okay, so I can say that the triangles are now congruent. Triangle ANX is congruent to triangle GRX. My reason for this proof for today, we're using side, angle, and side. We got 2 pairs of sides, and we got the angles in between. All right, let's move on to what's last here. So when we're looking at this proof, okay, some pre-observations and a plan for this proof. Okay, parallel lines, okay, often mean alternate interior angle theorem. And in the given, they give us some parallel lines, okay? 2 triangles sharing a side should trigger reflexive. And I have that in this picture. So I'm gonna have a step where I mark that red side congruent to itself. Okay, if I can do that, okay, I can, if I'm careful about my alternate interior angles, they already gave me the top's equal. So I have that the top equals the top, or the top equals the bottom, excuse me. Okay, if I put my alternate interiors right here and right here, now I can get the triangles congruent by side, angle, side. And that's what we'll do. So the given, we have a couple things in there. WX is parallel to YZ. That's going to be your trigger for alternate interior. And then we have that they're also congruent to each other. They're parallel and congruent to each other. Okay, now it doesn't matter what order steps 2 and 3 end up. Okay, let's do this red side, take care of that. So XZ has to be congruent to itself. Okay, but if you can see in this, XZ and ZX, they kind of flip the order. Sometimes you have to be careful with that with your reflexive step. Okay, we need an alternate interior step to get those blue angles. So that's WXZ has to be congruent to YZX. This is alternate interior angles. Okay, we can do that when we have parallel in the given. And now we're done. The triangles are congruent because now we have our 3 congruent signs. Okay, and our 3 congruent signs are 2 pairs of sides plus the angle that connects them, and that's called side, angle, side. Okay, don't forget definitions when you write proofs. So last thing, okay, if we are given that statement, if we're given the statement that segment BC bisects angle C, okay, this should say not BC, this should say DC. Okay, bisects angle C, that's this one. Okay, that lets us say that these angles are equal. So that would be angle BCD would have to be congruent to angle ACD. And what we're doing is we're just using the definition of bisector. Okay, if we're told that D is the midpoint of segment AB, okay, if this is in the middle of segment AB, even though it doesn't look like it, but we're not looking at it as being drawn to scale, okay, we would have BD congruent to AD by definition midpoint. And we already know, old news, CD is congruent to itself because of reflexive. All right, and that should be it for this video. Okay, you can have a chance at the 4.2b worksheet now. Thanks for watching. We'll see you soon.